Hello, everyone. How are we doing today?
Hello.
Hello, thank
Hello,
you.
everyone. Hello.
Yeah, today, Carlos will be presenting. I think you're using what was that thing again? Oh, he'll handle that. I just want to say welcome to our second item for the day, for the week. Hopefully you guys got my email today about the notes, the recording and the slides from last week, and then we'll let Dr. Taran take it from here.
Thank you, Maurice. Hi, everybody. So we are going to, let's wait just at least 2 more minutes to see if somebody, to wait for a few more audience, and then we can start. I will be sharing with you a Jupyter notebook that we're going to be introducing some main techniques to do data analysis with machine learning algorithms. So we will have fun later. Let's wait just for a few more audience.
Everyone, while we're waiting, go ahead and look in the chat and click on the link to access the copy of the Google Drive. The Google.
Dr. Ed, I see that the data set requires access. So when I clicked on it, it says like ask for access.
Oh, let me see.
Hold on, Carlos. Hold on there.
Let me change the setup. Hold on.
Yeah. Do you want us to send the request to you though?
Let me see if I can actually made it in order to not require access that you can.
Sure.
Let me.
Thank you.
Yes. Thanks for letting me know. Thank you. Okay, let's try the second one, the second link. That should, with the second link, you should be able to download the file, the data that we are going to be using for today.
Yes, that's working.
Perfect, thanks.
Do you want us to download or just view it in Drive?
Yes, you can download it because I want to show you how to upload it on OneDrive.
Okay.
So, okay, good afternoon, everybody. Well, today we are going to introduce Jupyter Notebook. In particular, we will introduce Jupyter Notebook with data science pipeline, how we can upload a file with how we can upload a file in Jupyter Notebook using Google Colab. So today we're going to use Google Colab. We have some open resources, limited, but are open and free to use. And we'll introduce a Jupyter Notebook using Google Colab, and we will do, in particular, healthcare application. You will see later what the data set is about. I have a short description in the Jupyter Notebook, and I will be sharing with you guys the Jupyter Notebook. So the idea is that you go along with me, and if you have any questions through the implementation, you can do the questions. You don't have to wait till the end to ask any doubts that you may have. Well, first thing first, let me share my screen and you will follow me and have a better idea what I'm talking about. Let's see. So can you guys see my screen?
Yes.
Okay, so this is the Jupyter Notebook that we're going to be working on. What I'm gonna do is I will share with you this link. And before to do any modifications, you are going to do a copy. I will show you how to do a copy because if you do a modification over the share link, that will show up in any others attending. So all the attendings that wants to follow me during the implementations, please do a copy instead of overwriting the file, okay? So I'm gonna share with you all the Jupyter Notebook. Let's put in the chat here. So let me know when you get there, and I will show you how to do a copy. And I want you guys to modify here. We are going to change the name just to make sure that nobody is working on somebody else's file.
Dr. Teran, did you put the link in the chat?
I think so. Let me.
Because I
No.
only.
Is the ones that say collab that. Oh, sorry. I was for directed to one person thing. Dr. Nelly. Yeah.
Okay.
So now, there you go.
All right. Here we go.
Thank you. It wasn't just to one internal person.
Okay, and now what do you want us to do to change the name?
No. Before, we are going to go to File, and save a copy in Drive.
Oh.
Yes. Once you download it or you click on it, you need to go on File, save a copy in Drive.
Okay.
And that will generate a new copy. And in that copy, we are going to set the name here.
Mm-hmm. Okay.
That's what we're gonna do first. Okay. So let me know when you all are ready. So I'm gonna do here my name.
Where is this file supposed to be?
That file should be on when you upload it. Should be in your Colab notebook in my drive. There should be options Colab notebooks, and it should be in that section. But to rename the file, you can do it actually up here at the top of the document. You can actually change the name.
Yeah, the thing is that I cannot find it in. Okay. Oh, here. Okay. Okay.
So let me know when you are ready. You can do a thumbs up to know that you all were able to download the file and do the copy and rename the file. Thank you, Dr. Muley. So what we will learn today is, in general, get familiar with a Jupyter Notebook using a Google Colab. We will do an application in data science for in the field of data science, in the particular in healthcare. The data set that we have is a heart disease. So we are going to train some machine learning models to classify if the patient has is disease with a heart condition or not. So it's a binary classifications. We are going to do a data pre-processing. We will explore the features that are involved in this research. We will know, or we will learn how to do a correlation in heat map. We will do the predictions. We will learn what are those libraries that we need to use in order to do a data analysis and train those models. In this activity, we are going to use three main models: support vector machines, decision trees, and XGBoost. We will also evaluate those models based on F1 score, the precision, the recall, and the ORC curve. So those are some of the skills that we are going to review, or that we will go over during this seminar today. To start, my name is Carlos Teram. I'm an assistant professor here at the CIS department, and I'm part of the data science cluster that is led by Dr. Alo. Let's just go over the applications that we're going to be working on today. So the heart disease is a common known cardiovascular diseases in a general term, encompassing various conditions that impact the heart and circulatory systems. It is lead cause of disability worldwide. Since the heart is one of the body's most essential organs, it is diseases can also affect other organs and body parts. There are multiple types of heart disease, with the most common ones involving narrowing or blockage of coronary arteries and multifunctioning heart valves. So we are going to experiment or learn with that particular data set. The data set was shared on the chat. So let me know if you were able to have access to that one. I just gonna share it again with you all, just in case that you missed the link. So that is the link. That link is a Google Drive. You will find a here.csv file that we will be using, or that we will need in order to amplify the concepts through the whole Python process of create a data science application. Okay. So we are going to work with the predictions. Mainly, we are doing a binary classification task. We will use some scikit-learn libraries in order to do that. And the XGBoost, we are going to use the SGBoost. So the idea is to basically understand the pipeline and the process that we need to do to implement a machine learning, or to train a machine learning model. We will understand in training the test process of a machine learning model, and we will evaluate the performance of these models based on different metrics that we are going to discuss here. Okay, so first thing first, let's talk about the main libraries that we need to use, or we need to import in our Jupyter notebook in order to do a data analysis. So we are going to work with NumPy. NumPy is a numerical structure that store numerical values. So we're going to be using NumPy to plot and to study our data. Pandas is a data manipulator for data analysis. We are going to be using that in order to upload our data file, and we will store it as a data frame. Okay, it's a data frame. We will use scikit-py. Scikit-py is well used to provide some mathematical statistical models to get some inside information from the data that we have. I also recommend a lot, if you are working with a statistical, or you want to get some insights and statistical information from your data set, I do recommend Seaborn. Seaborn has a really nice features, such for visualization and for statistical analysis. So Seaborn, we are going to be using Seaborn to plot or to visualize the data that we're going to be using. Then we're going to use also Matplotlib, which is the one that help us to plot or illustrate or do the visualization. The uniform from scikit-py, which will help us to do some tasks or print probability distributions. But mainly we are going to use Seaborn, because Seaborn is actually, that can help us as well to do or to plot the density or the probability distribution of the data set. Okay, so first thing first, what we're gonna do is just I'm gonna give you a brief interview about the Jupyter notebook. The Jupyter notebook, as you may know, it runs in Python. So that is the language that we're going to be using here to do the data analysis. How this works. So the Jupyter notebook is composed for cells. So we are going to create our code, or we will split the code amongst different cells. You can find two types of cells, the code and the text. So the code, if you create a code in here, that is to type your code. And then when you type the code, for example, let's do print hello world. And in order to run the code, or that piece of code in that cell, we need to go here, do play, and it will actually print the code. So we have to wait a few minutes while it is connecting to the server, and it will print. So that is the code cell. The code cell is where you are going to type your implementation. Now, we have the test code. The test code, if, for example, if you want to do any comments, or you want to comment your code or to know what that piece of code is doing, is also well used to guide others programmers to know what you are actually doing. So this part right here use a syntax that is called Markdown. Markdown syntax. Maybe some of you have used LaTeX. It's kind of similar LaTeX for type, for example, the formulas is kind of similar to display the formulas or to render the formula in Markdown. So Markdown is the syntax that this particular text in Jupyter Notebooks used. Okay, so for example, I just gonna type here this: hi, my name is Carlos Teran, and I will be your instructor. So this is Markdown. When I say,
where'd it go?
When I say that this is Markdown, so we can do actually like a title. If you see, we increase the font of the size. So we can make it a bold with the with this expression right here. So that is what we say that is a Markdown. So there are some syntax that you can learn in order to create your text or to customize your text in a Jupyter notebook. Okay, so these are the two different type of cells that we have in any Jupyter notebook. It could be in Google Colab or any other platform that you use. You will find those two potential cells that you can use. So any text that you find in here, that is actually written with a text cell and Markdown. Okay. Well, saying that, yes.
Before you go forward, so is this capability inside the Jupyter notebooks, or you still need to have a Python as a downloaded version on your computer?
No, in Google Colab, it already have a Python in it.
Okay.
Yes, we don't have to. Yeah, that's also a good thing using Google Colab in Jupyter Notebook, because we don't have to care about installing Python or Y particular version in Python. It comes with Python already.
Thank you.
Mm-hmm. You're welcome. Thanks for asking. So that's a good thing. But on the other hand, the trade-off is that it will work only if you have internet connection. Otherwise, it won't work. But nowadays, we can find a connection everywhere, right? Yeah. Well, this is, and also they have some resources. If I'm not wrong, you can request for a memory RAM and disk in Google Colab, and also there are some subscriptions that you can pay to increase the capacity of computational resources on Google Colab. But in FAMU, we are a partner from the national, the Nautilus, which is the national research platform where we can have some computational resources and run our own Jupyter notebooks on that platform. That topic is part of the third phase of this series. Well, so with the database that I give you and that do download, I will show you the way that we can upload that file. So here, if you see next to in your left side, you have like 5 options right here. So you want to go to the last one in the files, click on that one, and it will open this file right here. So what we want to do is upload. We want to upload our data file, which is the hers.scv file. You can do the way that I used to do it is you can do it up here. You can do click in here and it will pop up the window and select the file, right? You can just select the file. In this case, this is the file that I share with you. So hers.scv, we can open it. And we're gonna do okay. And here is the file. So this is the file. It's a CSV file that we will be opening, and we will open that file as a pandas or as a data frame in our Jupyter notebook. Okay, so data frames actually hold structured data, and it will help us to manipulate our the data set that we have. So this is once you upload the file, we are going to go here, the three dots, and I will do rename file. Well, hold on, let's do copy path. Sorry, let's do copy path. Do copy path. So again, one more time, I do the three dots, copy the path, and in the first code cell that we have in our Jupyter notebook here, what we are going to do is upload that information or that data set into our Jupyter notebook. So I'm gonna do here, where it's a path to the file, I'm gonna take that out and paste the content. So this is the path from that file. Who is PD? PD is the object where we are going to be calling any functions that belongs to the pandas file. But before of that, I was missing an important part. Let's go all the way up. So before of that, we need to run all these packages. So we need to import those packages into our Jupyter notebook. So let's run it. The first cell, this one right here. Let's run it. It will maybe take a few minutes. It will run it. So you finish. Now let's go back again in here. Now that we imported, who is PD? If you go all the way up, if you see, let's go to this one right here, for example, import, that's a keyword that we need to use in Python, the library pandas to create data frames. So this is the library and how you want to name it. So in this case, I name it as a PD. So that means that every time that I want to use any library from that package or from that, anytime that I want to use any function from that library or package, we need to use PD, which is for the pandas. You can name it if you want, but this is the standard name that the researchers or programmer does. So that means that if you find any other code that usually do PD, you know that that is for pandas, that somebody actually imported a pandas library. So read CSV, what the read CSV is a functions that belongs to that library. And there are many, many, many functions. So this is just one of them. These functions, what it does is actually help us to import information or to import the data that we have here as a data frame, okay, as a data frame. Now, how we can see what we imported. This is the code, so let's run it in here. You should be able to see this table right here. And that is just the first 5 rows. So that is printed because this line right here, data, that head is again, that is a functions that belongs to my pandas library, and it will print the 5 rows. If you want the first 10 rows, so you just do 10 in here and it will print the first 10 rows from your data frame. So these are the columns. Each row in our data frames will represent the record or the samples or data points, if you want to name it. So we have data points. So we have the data points. We have records or the samples. So here we have the samples, and the name or the feature of our data set is on the columns. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 features. So these are the features that we are going to be using. Those are the features that we are going to be using to train our model, okay? And the target, this is the target variable. The target tells us which patient actually is affected or is suffering by a heart disease. 1 means is affected and 0 means is not affected, okay? So this is our data set. This is our data set, and we are importing our data set as a pandas, okay, as a data frame. Any questions so far? So let me know if you were able to upload the data into your Jupyter notebook.
Well, I uploaded the data,
Mhm.
but when I tried to run it, it gave me some error. So maybe, you know, so I couldn't get the list the same way you got it there.
Did
Well,
you run this cell right here? This one, the second cell?
hold on.
It should be in green, like a check mark. If there is not a check mark, that means that you miss it. We have to run it.
Oh, okay, okay.
Mhm.
You see that. Okay, thank you.
Mhm. So if you run it, then you should be able to run this one, or it should work.
Mhm.
Well, down here, there is a short descriptions about the data sets that we are using. This data set, as I mentioned, have 12 features. One of the features is the age, sex, which is a word with a 1 and 0. So remember, when we are using with machine learning models, those are numerical techniques mainly, right? Those are numerical techniques. As a numerical techniques, we need to work with numerical values. We cannot work with strings. So that's why any numerical values that you have in your data sets needs to be transferred or turned into a numerical value to be able to middleware and run or train your machine learning model. So we have the CP chest pain type. So we have listed from 0 to 1. 0, that means a typical engine. We have a typical angina. We have non-angina pain and asymptomatic, which is from 0 to 3. We have the resting blood pressure, which in this case, the resting blood pressures. Let's see, that's one is this one right here that has a 145, 130, 130, 120. So that is the resting blood pressure. The serum cholesterol, which is milligrams per dl. The fasting blood sugar is 2 for 1 and 0 for false. Resting electrocardiographic results, we have 3 values for that one, 0, 1, and 2. We have the exercise included angina, that's a 1 in 0. All PITS, which is the depression induced by exercise related to the rest. We have the slope for peak exercise is the segments that range from 0 to 0, 1, and 2. A number of major vessels that go from 0 to 3. And the target, which is no disease and disease. The target is the labels that we will be used to train our models. Well, why do we need the target? So if you see in our data set, we have listed the features that we will use to train our model, but we also need the target. The algorithms or the machine learning algorithms that we will be using, that we are going to be using here, are supervised machine learning models. So when I say supervised, we need data with their label. So each of those rows or samples needs to be labeled in order to train the models, and the models can understand the patterns and then identify if the patient is a non-disease or disease, or is affected or not affected by the disease, okay, by the problem. So we will define a threshold in order to diagnose a heart disease. If the value is 0, is less than 50%, the percentage is 0. That means that is non-diseased. And if the value is the percentage is greater than 50, that will be disease. Okay, 0 for non-disease and greater than 1% will be the disease. So once we have that information, let's try to do a statistical information from the data set that we have. So now that we have imported data, we're going to use this object right here, data, in order to use or access any value from this data set right here, or the sample that we have. So let's go all the way down. In here, I'm gonna do a data that info. So data.info will give me a brief descriptions about what I do have in that data set. I'm gonna run it. And here is what we have. So the important part from this output right here is telling me if I do have missing information. When we have missing information, you will see that one of the number will be larger or less than the others. So in this case, we have 303 rows per age, sex, and all those features. And we have the target. So at this point, we can tell that we don't have missing information in our data set, okay? So now here, we want to drop some values. For example, we can drop or check if all those, what are the unique values that we have in our data set. For that, I'm going to use a for loop. I will show you. This is going to be a combination of a Python and the data science, a combination of both. So let's check each column and what are the unique values for each column. So for each column, sorry, let me see, column in. So remember, keep it in mind that data is actually the object that contains the information. In data.column, in data.column, we are going to find the unique values, data.column, and we are going to print that information. That will tell us what are the values or the range of the values that each feature has. So let's run it. And this is the information that we got right here. Okay, this is the information. And if you see, let me see.
Is this providing you just the range, or because I see unique values for sex, obviously we had ones and zeros given. And then
For 6, yes, it's giving us, what it is giving us is unique values that we have per each column. Why this is important? Because, for example, in age, right? There is, let's say that you find that there is a negative value. It doesn't make sense to have as a negative value as in this feature, right? So that's why this part is quite important, just to identify if any of those values doesn't make sense for that particular feature, we need to remove it.
Yeah, I'm sorry, maybe I missed something, but did we define the range to begin with, the age group? And then we're looking at the number which is outside of this age group?
You say to set the
So you say 63, 37, 41, those are ages, right?
yes, those are the
Yeah.
ages.
Okay, so what would be unique value? Do we calculate something like standard deviation or outliers or something like this, or?
Yes, we can do that. Yes, we
Okay.
can do that with standard deviation. Let me actually let's do that right now. So there is also a function that is called a statistic. Let's do data that let's see, and there is the info that description. So description is the describe, this one. Data that describe. Data that describe will give you exactly, I think, what you were asking for, the standard deviation, the minimum, the maximum value from each feature. So let's run that. If you run it, this is the count, how many values you have, the mean, the standard deviation, the mean value, the minimum value that we have, maximum value, and the different oh my God, I forgot the name. The different
quartiles.
Percentile. Exactly.
Percentile.
Yes.
I forgot the word.
Yes, that's right. the percentile, the 25, the 15, and 71. So this is a short description about statistically about the data that we have.
Okay.
Could you go back up for a minute? I was still working on the previous.
Yes, sure, sure.
Yeah, data.column, and I was looking at something else.
Yes.
Oh.
So this is mainly just to check, you know, if there is any maybe value that is not quite important or it shouldn't be there. But Dr. Nelly says now that she suggests that, so we can use the describe function that will actually give you the maximum value and the minimum value, and that will give us an insight as well if we are actually working with the correct range for that feature.
Thank you. Yeah, I got it.
Well, so now let's say that we want to drop some values just to do some examples and exercises here. Let's drop, for example, a value for this particular features, CA, this one right here, the CA. Let's do, for example, so we need to do data, word, data, and CA, the columns are, let's say, maybe less than 0. And for this one, let's do data, where the column, this one is equal to 4. I think this the ones that we need to drop, equal to 4. So let's run it. Well, hold on. Let me see what it provides. Now it removes all of the information. Let me do that again. Compile it again. There you go.
Yeah.
And data equals to data. So for example, let's say that we want to, let's work with just one of these. Where the age is greater than
70.
70. Let's do that. Where the age is greater than 70. So let's run it. But it says the length of the data is 6. Oh, sorry. I actually want to keep the ones. Sorry for that. Let me run this right here.
So you want to keep data for people who are less than 70. So that's why you reversed it, right?
So let's do
Or
that.
77. Was it 77? 70? Okay.
Yeah, let's do 70. And there you go. Now I want to keep those that are less than 70.
Yeah.
And now we have filtered the data. So this is the one of the way that we can actually drop those rows or those samples that we don't want to use in our study. So this is the query that we want to that we do, right? We want just to keep those or the Those samples where age is less than 70. Those one greater than 70 will be removed from our sample. And this is the data right now. So we move from 103 rows to 293. So here, something important when we are working with data set or doing data analysis is to maintain a consistency through the name of the features. So we are going to rename the columns of our data frame. So we are going to rename the column of our data frames, maybe to be more specific about what those features are. So there's something that is called in Python, something that is called pandas. And we are going to create now a pandas, a dictionary. We are going to create a dictionary and then redefine the columns of that, of my data set. In order to do that, we are going to define a dictionary, and this is the way that we will do it. But we are going to rename it as the following one. So the CP, we will rename it. This is the key, and we are going to do the value. The CP, we will name it as a chest pain type. Let me just go in here. Now let's do the resting blood pressure. So what we are doing so far here, just this line is defining a dictionary that will help us to rename the columns of our data frame. And that will help us to identify much better the meaning of each feature. So what I'm gonna do, I'm gonna share with you this piece of code so you can, to move on. Let me copy this part right here. I think I'm missing something. Comma, the parentheses, errors. So that should be fine. So I'm gonna copy that code. I'm gonna share it with you on the chat so you can copy it in the chat. There you go. So you can copy what I share with you in the chat and paste it in here. You can paste it in here. So let's run it. What we have done here is to name the columns and doing rename. Rename is a function that belongs to the pandas library. And now let's, again, we run our data frames, and as you see, now the name of the columns or the features are more readable, provide more insight about what that feature is. Yes, I will. When I finish the whole code, I'm gonna do, I will be sharing with you all the solution for this code. Yes. So now what we wanna do here, let's check if there is any null value. We already know that there is no null value. Why we know that? Because up here, we can see that all features are completed. There are no null value. You see here, that's why we know already that our data set does not contain null value. But there is another way that we can do it by using the isNull function from the pandas data frame library. So let's do that. Remember, again, we are doing that data because this is the way that we name our hers.scv file into our Jupyter notebook. That's why we are using data. So if we do data is null, that is null. This is another function from pandas is null that values that any. So if there is any null value, this will identify it and it will print, hey, there is a null value. So in this case, we didn't find any null value, so we are good to go. We don't have to drop any rows. In case that you have a null value for a particular row, you can then do the this thing here, right here. If there is null, so drop it. Well, let's explore the features that we have in the data set. To explore the features, let's first count how many patient per class we have. As if you remember, I mentioned that we are going to use, we are working on binary classification, okay? We are working on binary classification, just 0 or 1. So let's see how many patients has a non-disease and how many patients is diseased. And why that is important? Because that study will tell us if our data is balanced or unbalanced. If we have an unbalanced data, the performance of our models will not be the best. It will be actually overfitted by the unbalanced situation or the imbalance issues in our data set. So let's count how many samples we have per class, okay? So in order to do that, we are going to do data. Remember, the ones that has the labels or the columns that has the labels is called target, or at least here, the way that we name it is target. So we have target that, target that count, that value counts, and that will, I'm gonna take this out, and that will count how many samples we have per class. Again, that is important to see if our data is in balance or is balanced, okay? So now, what we're gonna do in order to plot or to visualize or compare how many samples we have per each category or per each class, we are going to use Seaborn. Seaborn will help us to visualize that difference, and Matplotlib. So the first things that we want to do when you want to visualize something is create the windows. The windows where you are going to plot that, that figure, right? Let me go all the way up just to explain you which library is the ones that we will be using. Is this one right here. This library is the ones that we are going to be using to create the windows where we are going to plot the figure. So we have Matplotlib, .pyplot, and PLT. So now you will see that we are going to use a lot the PLT. And I'm using the PLT because I'm calling that object for the Matplotlib, which is the one that will help us to do the visualization, okay? That's the reason why we are going to use Matplotlib. So let's create then the figure. This function, this command, figure, will actually define the window where we are going to plot our figure. So we have figure. Let's define how big or small the size of our window. So we are going to do it 6 by 4, 6 by 5. So this one is actually defining the size of your figure. So now let's do CSM. And now why I'm using CSM? CSM is the name that I set for the Seaborn library. This is the Seaborn library. Again, Seaborn library is well used for statistical informations and for a statistical visualization. So the Seaborn, and I'm using SM because that's the way that we define it as the object. So let's do that. Count, we are going to count plot. This is the function that we want, count plot. The axis will be a target, and I want to do data equals to data. So this is going to be the functions. So now we have create, I'm gonna do this next to as a comment. I'm gonna put it in here just for you to let you know what is going on here. And this one is for this one in here. Okay, so here we are creating the window, and in here we are creating the plot. So what is going on in here? This part is actually just customizing our figure, like setting the labels, setting the percentage per each bar, because here we are kind of using a frequency bar. So that's what we are plotting in here. So let's then run it. And you should have something like this. Okay, so everything that is going on in here, this part right here is to setting up the labels X, Y, the Y, the Z, and setting the percentage per class. So if you see, there are 45.7% of patients with a non-disease, and is 64.3 disease. Okay, let me just double check that was actually, yeah, no disease and disease, that's right. So we have 45.7% of the data or the patients is labeled as a non-disease, and 64.3 is a disease. So when the difference is quite large, we can do upsampling. So you can upsampling this the data for one of the categories to maybe be kind similar to the amount of sample from the others categories. So a statistical summary is actually what we did up here. This is the statistical summary, this one right here. Let's do it again. So this, to find a statistical summary, is data that describe, okay? That will tell you, again, the mean, the standard deviation, and the percentile per each, the percentile of your data set, the first, second, and third percentile. So, any questions so far?
Okay, as a non-data scientist, I'm getting into it, but slower. So you're going to send us the recording, right?
Yes, we're going to send the
listen to it,
recording.
yeah.
Yes, I will send the recording and the solution.
Okay,
Yes, I will do.
that's wonderful. Okay, thank you very
Yes,
much.
I will share with you the solution. Mhm.
Okay.
Yes. So I will, yes, we are running out, we are already run out of time, but if you have to jump out, that's fine. I'm going to continue. I will complete the Jupyter notebook and share with you all the recording and the solution of all of these Jupyter notebook. Mhm. Yes. Well, we have some function in Python. In Python, we use a reusable block of code to perform a specific task. So instead of repeating or duplicating the same information, we use functions, but I will actually go into that detail later. And I will show you what a function means in Python and how we can build functions and modularize our code and made it more readable and easy to use in Python. But I will exemplify the concept of function in Python later. Well, for now, what we are going to do is check and study the features. So let's see how correlated the features in our documents, in our data set are. So here, what we are gonna do, let's define the features. So here we are going to set what are the features that you want to study, okay? Let's see the features that you want to study. In this case, I just gonna, I'm interested in 3 of those. Let's say that these are the features that I want to work with. This one right here. Okay, the cholesterol, fasting blood sugar, and resting blood pressure. I want to check how related or similar are those features. Well, the for loop, again, I want to go over each of those features and identify or check the density distribution of those features and how similar the density distribution are between those three features. So in order to do that, we are going to create first, I don't want to erase it, we are going to create a set of sample. So for the set of sample, we are going to do data and data. Let's set the target because we want to associate it with the target. The target equals to target underscore values. This one right here. So in here, we are creating subsets of data points based on the target values. Remember, the target values are two, 0 and 1. Those are the two target values. Now let's create a KD plot that will generate the density distribution of those features that we are working with. So let's call the Seaborn, again, Seaborn, for the visualization and statistical analysis of our data. In this case, we are using analysis or the density distribution of our sets, features. So the subsets, we are going to do the subsets features, these features right here, subset features, this variable, and let's do label equals to, I'm gonna print actually the label. It's gonna be class and the target value. This one right here, to know which is the label that we are actually studying. So target value, perfect. And we want to fill equals to true. Perfect. That is to fill the area under the curve of our distribution. I'm gonna print it. And this is what I'm talking about. So what we are doing here is comparing how similar are the distribution of our features. If the distribution is kind of similar, is the same, that means that we have redundant information, so that those features is actually providing the same information to our to the model that we will train, and we can just use one of those. So this is one of the way that we can actually analyze those and compare the features that we have in our data set. Okay, so mainly the important part from this code is this part, which is the one that is helping us to identify or to compute the distribution of each features. Okay, this part right here, the KD plot. So now let's identify, let's create a list of features and let's analyze those list of features, but we are going to work with the numerical ones. So let's create here some features. And in this one, I'm gonna list a set of features to exemplify this part right here, okay? This is what I wanna do. Let's exemplify it. And let's actually visualize that data. To visualize, I want to do a per plot. So I just want to do the distribution of the numerical values and do the frequency table, a frequency table. So let's do that. And I'm just gonna do the per plot. And again, if you see, I'm using Seaborn, which is a well-used library, okay? That's the library that we have been using to do the analysis. So let's plot it. So this is another way that you can see how related are the features and the distribution between those between the features. Okay, so this is another way that we can visualize those patients that belongs to the category 0 diseased and non-diseased per features, how similar are or different they are from the diseased and the non-diseased patients in this case. Another important part in order to know which features you want to use is identify the correlations. Remember, if two features are high correlated, that means that those two features are actually providing the same kind of information, and you can remove one of those to optimize the training process of your model. So in this case, we are going to use the numerical values, numerical features. Let's use numerical features is going to be equal to data equal to, well, hold on, let's do data that select data types. Actually, it's giving me here the information, data types. And we are going to include numpys, but only numbers, okay? We will include numbers only. That drop. And we don't want the target column because that's the one that is giving us the label. So the columns equals to the target. So we don't want the target. We want just the numerical, and also we just want the numerical values from our data set to do this analysis. So now let's use again the correlation. Let's compute the correlation matrix for the numerical values. So we have the features, the numerical values right here. Correlation is going to be equals to numerical values dot correlation. So this is the correlation this is the metric correlations, the ones that we want to print. The metric correlation, and we want to identify the correlation for each value. Thank you. I will be sharing with you all the link. I'm gonna finish. If you need to jump out, that's fine. I just gonna finish the code with the recording. I don't know if Dr. Alo needs to do some announcements before to keep going.
Thank you, Carlos. Thank you. Yeah, let me take, this was wonderful. Absolutely wonderful. First of all, I want to thank everybody who's joined us today. This particular series, this was phase 2. In this particular series, we had phase 1 last week, phase 2, and I think phase 3, we have one more phase, I believe, in this, Carlos. Is that correct? Next week?
We have one more.
Yeah. Okay. But I want everybody to know something very, very exciting that we are going to be doing. Right after we complete phase 3, which is next week, we will start up a series on generative AI, generative artificial intelligence. And this is really important. And I hope that we can reach out to all across the campus, which is what we've been trying to do. Because, you know, when we start talking about generative AI and start using it, those that are afraid about programming, not having the coding skills, you know, they can come on board because, you know, it's a different game with generative AI. It's about modeling. It's not so much about coding. It's about modeling the problems, using our machine learning, our deep learning tools to create these models. And then, of course, the programming, we can give a set of instructions that will allow us to create the program. And so this makes a whole nother outlook for all of us and makes it a much easier way to get into utilizing machine learning and deep learning to help solve our problems. So we're very, very pleased that we're able to run this series. We will be running them every Wednesday, for the rest of the semester. And but also don't forget our Monday series, because our Monday series is about our students, undergraduate and graduate students, and the work that they have been doing. This past Monday, we had an excellent presentation from one of our students that attended the summer series at the University of Chicago Data Science Institute, in which he discussed an app called Seedbot that is important for the farmers in identifying, in working with seed laws. What's neat about this is no background in natural language processing. Within 10 weeks, within 10 weeks, he was able to create an app that we're very, very interested in seeing how it can be patented. And we're putting him in contact with our technology transfer expert, David T. The previous week, we had a similar instance, another student creating within a 10-week environment an app that is also very much, I would say, patentable. It is using AI to identify food. We were very fortunate to have the dean of our allied health program there. And immediately we recognized how important this app could be, for example, in healthcare, hospital, in the hospital dining rooms or in their cooking facilities. Anyway, my point being, here are two students. Their backgrounds in AI and machine learning started up in a 10-week period. They had to build that foundation. And then within that 10-week period, they were able to actually, after a hands-on, project-activated approach, create something very worthwhile for society. So yeah, please attend our Monday series for our students. And we're looking forward to continuing the Wednesday series. Thank you, Dr. Doran Saras. We appreciate it. And thank you all for coming.
Thank you, Dr. Alo.
Thank you. Thank you very much.
So actually, I don't know if we can finish here for today. I don't know, Dr. Alo, what do you think?
Oh, it's fine.
In that way, we can continue working on these projects. We
Yes.
have just a few things which is quite important, is the evaluation, the training process, and the evaluation of the model. I think that we can stop here. I can share the solution from what we have so far. Continue from this point next week.
All right, that sounds fine.
Yeah. So, Erdal, can we get out a flyer that will have the list of presentations over the next, say, 10 weeks for the Wednesday presentations and also for the Monday student presentations? This would help the faculty and staff and students know, what's coming up and what to expect.
Yes, I can definitely work on that for you.
Okay, thank you. Carlos, did you want to do any more, or are you through?
Well, I think that there's suggestions we can continue next week. In that way, if any faculty have any question or doubts, we can clarify it, during the meeting, and they can also follow at the implementation in life of the application.
Any questions, anybody? We will be sending out a survey, by the way. We do this every week, and I hope you can give us your feedback. We really want your feedback. I understand, there's always a threshold when new technologies come on board. And we're discussing on how to handle that. We are going to be working on developing small teams of faculty working with our data scientist. In other words, we are thinking of having faculty or student teams of probably at most 3 working with one of the data scientists and actually hand holding, so to speak, to get you on the National Research Platform. We have tremendous free resources on the National Research Platform. We have over 5,000 data sets that can be used for teaching and learning. We have over 100 modules that already are created that can be shared, that are infusing AI, machine learning in subjects across the curriculum. And of course, as you create such modules, they can be uploaded to the National Research Platform and be shared with more than 100 institutions that are already on that platform. But the other important thing is we have graphical processing units. We have GPUs that if you need one, we can let you use it. You have access right now to 8 GPUs on our system. We have 24 in reserve that will be added as soon as we get more activity. But the important thing is on the National Research Platform, once you get connected, you have access to over 1,300 GPUs. So whatever the size of your problem is, whatever the size of your research is, we have the capacity to handle that. These are free shared resources for research and learning modalities. And so, for example, we're working with the College of Pharmacy on using deep learning, on how to use deep learning to automate synthetic drug development. Well, these GPUs will come into play as an example. Gen AI will be very helpful to them in getting them engaged with this very important project of automating the development of synthetic drugs. So thank you, everybody. If there are no questions, I appreciate you all joining us. Thank you.
Yes, I think that Dr. Metaba, we are going to keep working, complete the whole process and the pipeline. And the next sections, maybe we will take a few minutes to complete it. In that way, all the faculty that is attending the meeting will have the opportunity to ask the questions at the moment and clarify any doubts that you may have. So in the pipeline, what we will work for next week is the correlation heat map to find out the correlation between the different features that we have and the predictions. We are going to train the models. We will see how to train the models, how to split the data between training and testing. And important part, the model evaluation. We will see the different metrics. We will explain what those metrics is telling us and the interpretation of those metrics, as well as the ORC curve that is quite important when we are using binary classifications for the sensitivity interpretation. So that's what we are going to be working and complete then the next week. And thank you for your time and patience as well. We take a few more time than expected.
So if there are no more questions, then we'll sign off, okay? I didn't see any more questions in the chat, did you?
No.
Okay.
Not right now.
Okay. Thank you, everybody.
So we are going to be sharing this link with you all.
Okay.
Okay. Thank you, everybody.
All
Bye
right.
now.
Bye.
Bye.
Bye.